Okay, in this video, the learning target we're going to talk about is I can solve projectile motion problems. So projectile motion problems are when an object's either been launched, thrown, or it's some sort of object flying through the air because force has pushed it through the air. So the equation that we use for projectile motion is the height of the object equals negative 16 t squared plus v0 t plus h0, where the t represents time, and then these pieces, the negative 16 is the acceleration due to gravity that's affecting the object in the air, the v0 is the velocity of the object, and then the h0 is the starting position that the object was either launched or thrown from. So we're going to use this equation and we're going to look at some examples of using it. So in number one, it says you drop a water balloon off a tower that is 750 feet tall. We need to write an equation to model the height of the water balloon over time and then figure out using that equation when will the water balloon hit the ground. So to kind of just draw us a little diagram here, picture that there's a tower at 750 feet tall. You're standing at the top of this tower and you drop the water balloon off the tower. Okay, so it's going like this. Okay. The first thing I want you to notice is that it's like a parabola, but it's just the half side of the parabola, right? You're at the top. When you drop it, it's going to slowly kind of drift away from you and then kind of just go straight down. Okay. So we get this path of the water balloon, and we're going to use this equation again to solve it. So it's going to be h of t equals negative 16t squared. Okay, this will always be the same because gravity affects it the same. Okay, it's a gravity constant, so it's negative 16t squared. Then for the next term, remember it's your velocity. Well, if you drop something, right, like if I'm holding something, I just drop it, I let go, I'm not putting any force into it. So it's actually starting with an initial velocity of 0. Okay, I'm just letting go of it. I'm not actually throwing it. So it's just 0 there. So 0t. And then I'm going to add the height that it started at. Well, it started at 750 feet. So we add 750 feet to the end of our equation. Okay, so we get the height of the object at t seconds is equal to negative 16t squared plus 0t plus 750. Okay, and it's important to note that the time here is in seconds. Okay. All right. So let's use this equation then that we just wrote to figure out when will the water balloon hit the ground. Now the trick here is understanding what it means by hitting the ground. So when an object hits the ground, okay, it started at 750 feet up. When it hits the ground, it's at a height of 0, right? So what we need to do is we need to plug in for our height, right? This piece, our height here, is 0 when it hits the ground. So we're going to write it as 0 equals negative 16 t squared plus 0t plus 750. Okay, so our initial height was 750, but our ending height we know when it hits the ground is going to be 0. So this equation is going to be equal to 0. And then we want to solve this guy. Now I'm going to solve this. There's multiple ways to do it, but I'm going to solve it using the quadratic formula. So to do that, remember it's going to be your variable equals the opposite of b. So in this case it's 0, so the opposite of 0 is just 0, plus or minus the square root of b squared. Well, that's going to be 0 squared minus 4 times your a, which is negative 16, times your c, which is 750. Okay, and then we're dividing by 2 times the a, which is, once again, negative 16. We're just going to simplify this down. You're going to want some sort of calculator when you do this. So to start, 0, negative 0 is just 0, right? So that basically is gone. That's just going to go away. And then I'm going to simplify this piece. So I'm going to do it over here. We're going to get t equals the square root. Well, 0 squared doesn't matter, right? That's going to be 0 squared is 0. So this is going to go away as well. I just need to multiply -4, -16, and 750 together. So using my calculator, I want -4, I want -16, I want the 750, and I get 48,000. Okay, so underneath the radical, I get 48,000, and then that's being divided by 2 times -16. Well, that's just -32. Then I need to take the square root of this number, right? I want the square root of 48,000, so I'm going to type second, and then you'll see where it says x squared, sorry, on your calculator, where it says x squared, you'll see right above it, there's the square root symbol. If you click second and then that button, it'll put a little square root here on your calculator, and you can just type in 48,000, hit enter, and it's 219.09. So we get t equals plus or minus 219.09, and we're dividing by -32. Okay. Remember, once again, there's a plus or minus on this, so this needs to have the plus or minus. Now, the trick here is when you're thinking about time, when you're dropping an object, you can't have negative time, right? That wouldn't make any sense. Like the object is falling and it's positive time as it's falling. So this next calculation, I want to do the calculation that's going to allow me to have the time be positive. So because the bottom number is negative, I need to take the negative 219.09 divided by the -3, because when you take a negative divided by a negative, it makes it positive. So to do that, we're going to take negative 219.09 and we're going to divide by 32. And when we do that, oh, I'm sorry, divide by a -32. Our answer here, so I made an error. I should have divided by -32, which would have made this positive 6.85. So you should get positive 6.85. Now, this is our time that it takes for it to hit the ground. So this is the answer to this problem. When will the water balloon hit the ground? It's going to be 6.85 seconds. Okay. All right, let's go ahead and look at another example of doing this. So number 2 says a ball is thrown with an initial velocity of 32 feet per second. So we're just going to put a little V by that guy. The ball leaves the person's hand at a height of 5 feet above the ground. So that's my H0. That's the starting position. And then it wants me to write a function to model the height of the ball over time. And remember, time is in seconds. And then how long will the ball be in the air if no one catches it? Or how long will it be before it hits the ground again? So we're going to write h of t. Okay, the h of t stands for like the final height of the object is going to be equal to -16t squared. Okay, remember this stays the same because gravity is constant. And then we're going to add 32t because I've put an initial velocity of 32 feet per second into it. Okay, so I've put force into this because I'm throwing it. And then it's leaving from a height of 5 feet, so I'm going to put plus 5 on the end. Okay, this is going to be the equation that's telling me the final height. Now, I want to know how long the ball will be in the air if no one catches it. Well, if you think about throwing a ball for a second, okay, so here's a person, they release the ball goes, and then it comes crashing to the ground. If no one catches it, it's going to hit the ground again, right? And when it hits the ground, its final height is going to be at a height of 0. So once again, we're going to plug 0 in for the final height to give us 0 equals -16t squared plus 32t plus 5, and then we're solving this for t. Now, this is a standard form quadratic, right? We can solve this once again using the quadratic formula. It's going to be t equals the opposite of b, so that's -32, plus or minus the square root of b squared, so 32 squared, minus 4 times my a, which is -16, times the c, and then it's going to be divided by 2 times my a, which is -32. And then I'm simplifying this. Now, I usually simplify the radical first, so everything underneath the square root I want to do first. So starting with the 32 squared, if I take 32 times 32, I get 1024. Okay, so I can rewrite this guy as t equals -32 plus or minus the square root 1024, and then I'm going to multiply these three together. So if I do that real quick, I want -4 times -16 times 5, and I get 320, and that's positive. So adding 320, and then everything is getting divided by -32. Okay, so now I'm going to put those two guys together. So if I add those two together, I want to add 1024. I get 1344. So t equals -32 plus or minus the square root of 1344, and then I'm dividing by -32. So t is going to equal, and then once again, I want to actually get the square root here. So I'm going to click second to get the square root of 1344. And I get 36.66. So -32 plus or minus 36.7 if I round it, and I'm dividing by -32. Now, this is where, once again, you have to think about the calculation we want to do. Do we want to use the positive or do we want to use the negative when doing this calculation? Remember, when you throw an object, the time isn't going to be negative, right? The time we should get should end positive. So to do this, if I take -32 plus 36, and if I do the adding, well, 36 is bigger than 32, right? So the top number would be positive, and I would be dividing by a negative. Well, positive divided by negative would give me a negative, right? So because the positive ends up giving me a negative time, I don't want to do the adding, okay? Instead, I'm going to subtract, because -32 minus 36 will give me a negative, and when I take a negative divided by a negative, I'll get a positive, okay? So we're going to do the subtraction here. So I'm going to take -32 minus 36.7. So the top number I get is going to be, I'm going to write it in some space here, t equals -68.7, and then I'm dividing that by a -32. So if I divide that by -32, we get, sorry, if I take this number and divide by -32, we get 2.15 approximately. So 2.15 seconds is how long we would expect the ball to be in the air. Okay, so hopefully this video was helpful. Remember once again that projectile motion, you're using this equation. The h of t stands for your final height of the object. The -16 is the acceleration due to gravity. The v0 is the starting velocity. The h0 is the starting position, and then t is the time, and it's in seconds. Okay.